Stop wishing on shooting stars. Seriously, the object you see burning across the night sky isn't a star, and it definitely isn't magic. It is a violent, high-speed collision between Earth and a piece of cosmic trash. What if I told you that the bright flash you see isn't caused by a massive rock, but by something the size of a grain of sand? That tiny speck hits our atmosphere with the force of a bomb, and understanding why it glows tells us everything we need to know about how Earth shields us from the universe. For thousands of years, humans have looked up, seen a streak of light, and made a wish. We call them shooting stars or falling stars. But the name is a lie. Stars are massive balls of burning plasma light years away. If a star actually fell to Earth, we wouldn't be making wishes, we would be vaporized. So, what is really happening up there? You are witnessing a suicide mission. You are watching a piece of ancient debris slam into our planet's air shield at 160,000 miles per hour and tear itself apart atom by atom. Welcome to Space Facts. Let's find out what you've been wishing on. The biggest misconception about shooting stars is their size. When you see a blinding streak of light that cuts across the entire sky, you probably imagine a rock the size of a car, right? Wrong. Most shooting stars are tiny. We're talking about the size of a pebble, a pea, or even a grain of sand. So, how does a grain of sand create a light show visible from the ground? It comes down to one thing: kinetic energy. In space, there's no speed limit. These rocks travel at tens of thousands of miles per hour. That's 50 times faster than a rifle bullet. When they hit the Earth's atmosphere, they trade that speed for heat. Because energy scales with speed, a tiny pebble moving at 45 miles per second carries the explosive energy of a stick of dynamite. The flash you see is that energy being released all at once. Here's a fact that stumps even science teachers. If you ask someone why a meteor gets hot, they'll say friction. They think the rock is rubbing against the air molecules like sandpaper. But that's not the main cause. The real reason is something called ram pressure. The meteor is moving so fast that the air molecules in front of it can't get out of the way fast enough. They get trapped and compressed against the front of the rock. Think of a bicycle pump. When you pump it really fast, the valve gets hot because you're compressing the gas. Now, imagine compressing gas with a rock moving at Mach 50. The air in front of the meteor gets squeezed so hard that it turns into a superheated plasma, reaching temperatures of 3,000 degrees Fahrenheit. That glowing trail you see isn't actually the rock itself. It's the air around the rock catching fire. And if you look closely, you can sometimes see colors. This is the chemistry of the universe burning up. If a shooting star looks yellow, it's likely made of iron. If it flashes blue-green, it's rich in magnesium. If it glows purple, it's full of calcium. You aren't just seeing light, you're seeing a chemical analysis of a rock from deep space. But where do these rocks come from? Why do we see them more of certain times of the year? Most shooting stars are actually comet dandruff. Comets are dirty snowballs that orbit the sun. As they get close to the sun, the ice melts and they leave a trail of dust and rock behind them, like a dirty dump truck driving down a highway. These trails of dust stay in space for centuries. Every year, as Earth orbits the sun, we drive through these old dust trails. When we hit the trail left by Comet Swift-Tuttle, we get the Perseids meteor shower in August. When we hit the trail of the asteroid Phaethon, we get the Geminids in December. This is also why meteor showers look like they are coming from one specific point in the sky, which we call the radiant. It's an optical illusion. It's the same reason why railroad tracks look like they merge in the distance. The meteors are traveling parallel to each other, but because Earth is slamming into them head-on, it looks like they are bursting out of a single spot. However, not everything burns up.
If the rock is big enough, say the size of a basketball or a couch, it might survive the fiery plunge. But survivability isn't just about size, it's about material. Most meteors are made of stone, which is brittle and breaks apart easily under the pressure. These usually vaporize completely, but about 5% of them are made of solid iron and nickel. These are the heavyweights. They can withstand the intense heat and punch their way through the atmosphere to hit the ground. We actually have 3 different names for these objects, depending on where they are in their journey. When the rock is just floating in deep space, doing nothing, we call it a meteoroid. But the moment it hits the atmosphere and creates that flash of light, it becomes a meteor. And finally, if it manages to survive the fire and land in your backyard, it earns the title of meteorite. If you find a meteorite, you're holding a time capsule. These rocks are often older than Earth itself. They're leftovers from the formation of the solar system 4.5 billion years ago. Some of them even contain tiny diamonds or amino acids, the building blocks of life. So, a shooting star isn't a star at all. It's a final, violent moment of glory for a piece of space dust that has been drifting in the dark for billions of years. It ends its journey by becoming a streak of plasma in our sky, protecting us by burning up so it doesn't hit our heads. The next time you look up and see that flash, go ahead and make a wish. But remember, you're wishing on a piece of burning rock that just lost a fight with our atmosphere. If this ruined the romance of wish-making but made you smarter, hit that like button. Subscribe to Space Facts for more truths about the cosmos.